Now question number 22 is the number of 3-digit numbers ABC such that we can construct an isosceles triangle with sides A, B and C. Now if it is isosceles, then two sides they'll be equal. So we'll consider this case when A equals B. So we have this triangle. Here we have A and C. Now these three lengths will form a triangle if sum of two sides is greater than the third side. So that means C is less than 2A. Now if we take A as 1, we get C is less than 2. Then the condition is C equals 1. If we take A as 2, we'll get C less than 4. The value of C are 1, 2 and 3. For A equals 3, we'll get C equals 6. So C takes the value from 1 to 5. A equals 4. C less than 8. So here C takes the values from 1 to 7. A equals 5. C is less than 10. C takes the value from 1 to 9. And from A equals 5 to A equals 9. For all these cases, we'll have C from 1 to 9. Now, how many cases are there? So we have this one case, then 3, 5, 7, and then from 5, 6, 7, 8, 9. So for these 5 cases, we have 9 values each. So it'll be 5 into 9 and there'll be 45 plus 5, 50, 50, 60 and 61. So it'll be 61 cases. Now there'll be 3 such possibilities. Either A equals B or B equals C or C equals A. So total number of such cases will be 3 into 61, which is 183. Now here we have a problem, and the problem is if the triangle is equilateral, that is when the value of A equals B equals C, we have counted this case for each of the 3 cases. So that means we have some repetitions here. So first we need to find how many equilateral triangles will be there. So for 9 cases, there'll be 9 equilateral triangle. So from these total cases, we'll subtract these equilateral triangles 2 times because we have to include them once, but we are not going to include them again for the remaining 2 cases. So it'll be simply minus 9 into 2. So 183 minus 18, and it'll be simply 165, and that's your option C.